Hi everyone, this video is for section 2.2. We're going to be solving an inequality, and then we're going to be providing our answer in inequality notation, interval notation, as well as representing it on the number line. Not necessarily in that order though. So the first thing that I want to note here is that I only have a right and a left side. So I'm just dealing with an inequality as opposed to a compound inequality where you essentially have that third middle piece. So before we actually begin to solve this problem, we would want to clean up both sides. So for example, I'm noticing on the left, I do have grouping symbols. And in order to really do any work, I need to clear them. So I'm going to use my distributive property, which is telling me that since the 2 is being multiplied by that grouping, I need to multiply each term within the grouping by the 2. So my result in this case is going to end up being 2 times negative 5x is going to give us negative 10x. And then we're going to do 2 times a positive 5, so that's going to give me a positive 10. So that's going to be how I'm going to determine what symbol I should have between the 10x and the 10. Since it's a positive 2 with a positive 5, I'm going to get a plus 10. And then we'll have our plus 31. That just follows along because it is not in the grouping symbol, so it does not get multiplied by 2. And we're going to do less than, and now we're going to come over, and again, I see that I have grouping symbols here. So I'm going to use my distributive property to distribute that negative 4. So please note that the entire value has to be distributed. That negative has to go along with it. So a negative 4 times a negative 2x will give me a positive 8x, and then a negative 4 plus 1 will give me a minus 4, or negative 4. And then again, that minus 3x is not in the grouping, so it's just going to come along for the ride. I'm going to take this further, and I'm noticing, for example, on the left-hand side, I do have some like terms that I can combine. So it's all about the cleanup before we actually go for the solution. So I see that I have a positive 10 and a positive 31. So that means I'm going to have negative 10x. And then if I add these two values together, I'm going to get a positive 41 is less than, and now let's turn our attention over to the right-hand side. And in this case, I'm seeing that I have a positive 8x and a negative 3x. So sometimes what happens is people look at this and might think that things have to be treated differently because there's a variable next to each of those numbers. So what I am telling you here is that we are just going to combine like terms. So in this case, I have a positive 8x and a negative 3x already on the same side, so I'm just going to combine them. So this is going to result in a positive 5x, and then the minus 4 follows. So again, this is because, so the minus 4 just drops down because there are no like terms on the right-hand side to combine it with. Much like how the negative 10x just came down to the next step because there was no other term on the left side with a variable of x with it. So now we can actually start to get after our goal. So our goal is we want to find out what x is going to be, in this case, possibly less than 2. So what I want to do is I want to essentially get all of my terms with an x to one side, and that's not necessarily 100% correct in saying that, and I'll explain that in a moment. And then we want to get all of our constant values to the other side. So what I'm actually saying here is that, for example, if I want to get x to the left-hand side, I'm going to remove a 5x from both sides. So that's going to clear out here. So what I want to be clear about is I wasn't necessarily 100% correct in saying that I'm moving something over. What I'm actually doing is I'm eliminating it so that the x value only exists on the left-hand side. So in this case, if we eliminate a 5x from both sides, I now have a negative 15x plus 41 is less than negative 4. So again, we want to work with this idea of eliminating. I want to eliminate the plus 41 on the left-hand side so that the x value or the x term is the only thing there. So in order to eliminate a positive 41, I'm going to eliminate it by subtracting 41 from both sides. And again, that goes away. This is going to leave us with negative 15x is less than, and that's going to give us a negative 45. So continuing to talk about this idea, I have a negative 15 times x. That's essentially what that's saying whenever you have a number and a variable written right next to each other with nothing in between. So in order to undo that multiplication, I'm going to divide both sides by negative 15. So note here that, again, what I do to one side, I must do to the other, because it's all about that balance. So as a result, we will have x, and I'm going to go straight to the number piece here. So negative 45 divided by negative 15. So a negative divided by a negative will give me a positive number, and it's going to be a 3. What I want to note here is that I used a negative number to do the division on both sides. So that means that I have to flip my sign. So instead of a less than, I now have a greater than. My solution is going to be x is greater than 3. This is the inequality notation. I'm going to scoot this up. So the next one that we're going to look at is going to be the number line. So I'm just going to draw a horizontal line here. I'm going to put 3 in the middle, and I might just put 4 and 2 just to see those numbers. We don't have to start from 0 or show any negative values if we don't necessarily need it. So because I am just dealing with a strict inequality of greater than, that tells me that I should use an open circle. And as was noted in class, if you write your inequality so that it is variable first, followed by inequality, followed by number, your inequality is literally telling you which direction to shade. So as you can see, I'm being pointed to the right. So my shading should be going to the right-hand side. We also can get our solution by simply reading it. X is greater than 3. So which side would I shade if I want all the values that are greater than 3? We shade to the right. So finally, our interval notation, remember that our interval notation is going to go from the smallest number first to the largest number. So in this case with my shading, my smallest number that I worked with was a 3. My largest number went off to positive infinity. In order to finish this off, we have to ask ourselves, do I use parentheses or brackets on each side? We have to ask that question twice. So with a 3, because this is an open circle, or because this is a strictly greater than, we're going to use a parenthesis. That tells us that the 3 cannot be included in our solution. We can only get really, really close to it. So we can use like 3.01 or 3.000000001 and so on. And then with the infinity symbol, we always use a parenthesis because infinity isn't actually a number, it's just the idea of a number that's constantly getting bigger and bigger. So the last part of this that I want to talk to you about would be how to check your work if you are still unsure. So what I would suggest doing is use your inequality notation. This would be a quick check. And then just simply working with numbers in both the non-shaded area where your dot is and your shaded area. So in the first case, if I say worked with 2 and plugged it in, this inequality would say 2 is greater than 3. So that's not true. The other one, so if we work with our dot, would be 3 is greater than 3. That also doesn't make sense. We're getting closer, but that's still not right. Lastly, if we pick something like 4 is greater than 3, this works out. What I would also suggest doing, if you are not sure if you've done all of your calculations correctly, would be to actually come all the way up to the original problem and plug your values in for your variables and do your work. I hope that this video helps. If you have any questions, please let me know.